Hey guys, it's Vince. Today in this video, we are going to be discussing a topic I've never really seen discussed in a way to make everybody understand how critical selecting a cable chain is. And not only the cable chain you select, but understanding minimum bend radius when working with your cables. I had an issue that came about. It actually at first made me angry, and many of you are going to see as we go through this video, which is going to be pretty long because I have a lot of detail to cover. So if you really want to pay attention to it and watch it to the end, which I hope all of you do, you got a lot to learn, it's going to be worthwhile to watch. And this issue really made me think for a couple days of how I could solve it. And I really thought about how much information is out there about really selecting a cable chain. So what I wanted to do is do some research myself, see if anything is out there before I put something together, and I actually found a great article, and we're going to cover that. And I also figured out a viable solution to the issue that occurred. So I feel it's a different approach, but it's a great way to make everybody learn who's out there and working with whatever type of cables you're working with CNC, whether it be for motors or spindles, whatever it may be, understand how critical this component is for your system. So what we're going to do, I've already got the article up. Actually, I got a couple articles up, so just bear with me. I have here selecting a cable drag chain, and I found this, believe it or not, on an Instructables website, which is pretty amazing because this is one hell of an article. It was written by Ryan McKenzie. Very, very well written, very well thought out. And he's basically explaining how to select the proper cable chain. He goes into all of the details. This is stuff that I've covered many times in terms of discussing it personally with clients, but I haven't done an actual video on it. So it really pays to sit back and watch this because it's really going to take over as far as what you think you may know. You may actually learn some more. It's definitely worth listening to. It can definitely save you a lot of money as well. Basically, we can read the whole thing. There are so many of us with hobby CNCs out there. I thought I would share some professional knowledge on a topic very seldom covered in our favorite CNC forums. Cable chains carry the power and signals needed to get the job done. Often the cables are cheap enough to replace, but it is a hassle of doing the job that's time consuming. I kind of disagree with that. Cables are very expensive, depending upon what cables you're using. The bigger problem is when the cables fail during the process or trying to fault find those missing steps on cables with broken internal cores. And this is where things get interesting. When designing cable chains, care needs to be taken when selecting, firstly, the type of chain carrier, and secondly, the type of cables to be fitted in the chain. Followed by the layout of the cables in the chain, most of the major chain manufacturers have some documentation detailing how to choose and set up their chains to ensure the longest lifespan of both the chain and its contents. Following those guidelines to the letter would ensure lifetimes typically in the 10 million cycle range, but would also produce excessively wide chains that would not easily fit in their applications. A compromise to having the idea chain is to stack cables on top of another, therefore reducing the overall width of the carrier and cycle life. Stacking cables in a chain is not recommended by the manufacturers, but they realize there are applications that call for a reduced carrier footprint, and their design guidelines cover this. The guidelines for stacking ensure cables will be able to move freely with minimum friction and reduce the ability of cables tangling. I've taken this info from guideline emails, face-to-face meetings from the 4 major manufacturers in Europe. So I hope this Instructable will help you get the best lifetime out of your chains. Due to the formatting here, I have included a PDF with slightly better formatting at the end. So you guys, I highly recommend you go to this link, check it out. I will put it in the video at the bottom in the description so you can check it out because, again, wealth of knowledge here, really, really important stuff. To determine the required carrier system inner cavity, you can see here cavity area. And we're coming over here, cables add 10% to the outer diameter. Minimum clearance on the outer diameter must be at least, and they're saying right here, you can add 10% to the outer diameter, add 15% to the outer diameter for pneumatic lines, hydraulic lines. Many of you are not dealing with pneumatic lines. We're just dealing with cables. The largest of these cables, air line or fluid hose outer diameter values with the safety factor added, determines the inner cavity height required. And then it says make notes. And again, he's got all of your actual calculations here if you want to do the formulas, but right here it sums it up. And this is important information. Clearance. To determine if the required carrier inner cavity height high is sufficient. Cables add 10% to the outer diameter of your cable. Minimum clearance around ODX must be 1 millimeters, and again, we're saying less than actually greater than 1 millimeter, excuse me. Pneumatic lines add 15% to the outer diameter. Minimum clearance around outer diameter equals X must be greater than 2 millimeters. Hydraulic hoses add 20% to the outer diameter. Minimum clearance around the outer diameter X must be greater than 3 millimeters. The largest of these cables, airline, and once again we're back in for the safety height, and this is what they're explaining. Now, what's interesting here is I have never seen anyone really think about it at this capacity because, again, when you get into full-scale automation, this is the parameters that they will use. Many guys think they just stick their cables inside a chain and they're good to go. And unfortunately, that's not the case. If you put cables inside of a cable chain that has not been fitted properly, and you overload the cable chain, and we'll go that, once again, we're going to pan through this actual article together, and you'll see what can happen and what many of you have experienced, may not even know your experience currently. But if you do that, you can inefficiently and inadvertently create premature cable failure, all types of cable issues as far as signal disruption. And again, this article is imperative for those of you out there trying to do it right. And that's who I'm really focusing on. So we can see here, he actually has pictures, and this is what's cool. We can blow them up. You can see space in each cavity partition allows for the cable hose outer diameter plus the recommended safety factor. You can see the distance here. This is what's so important. You can see the red arrows. He's showing you that the cables have space. They're not just actually fitting in the cable chain. And I hate to say it, guys, many guys online feel that this is acceptable. It's not. When these cables move, you want to have them move with the minimal amount of friction. Okay? And when I say minimal amount of friction, I mean virtually no friction. Okay? Bottom line is this: when cables move, they will bend in all directions. It's inevitable. If you confine them improperly, whether it be with minimal spacing where you see here, or if we had this cable chain overloaded with cables, we'll cover that later, you will get basically the same effect: massive amounts of friction and massive amounts of pull and push, especially when our axis move fore and aft on the Y, on the X. That's when you typically see that, and you see cable degradation. Okay, weight distribution. This is the good. You can see they balanced it with the two smaller and the larger on the outside. Not recommended. You have the two larger there and the smaller on the inside. This I've seen done numerous times as well. Cable hose weight is evenly symmetrically distributed inside the carrier cavity, allowing the balanced carrier system operation. This is ideal. And it's just logical. A lot of this stuff you'll find, we don't need to get into the science of formulas and whatnot. If you just use the pictures, you're going to be fine. What I usually find, and this is about 98% of CNC, at least at this capacity, again, more civilian based, everything now is based around finance. And when I say that, guys will cut corners any way they can to get that machine running. What they forget is, at what risk are you cutting those corners, and what are you creating in terms of demons later on? And that's what's never, ever figured out. And I see it time and time again, and many of you see it time and time again. Pardon me, I just got to get a drink. Okay. So overall, we can see now we have a pretty good assessment here. And again, you can see add up all the aforementioned cables, airlines, fluid hoses, plus safety factors, and that's how you'll come to this. We already went over the actual calculations to do that. Again, if you're going as large as you can go, 3-4 millimeters, even up to 5 millimeters in clearance over the cable, you're good to go. You want the least amount of friction possible. We don't want those cables bouncing around and rubbing on the top, sides, left, right, all that neat stuff. The more room you have, the better off you are. Okay, now, to determine if the required carrier system inner cavity width B is sufficient, use the formula in the second range, okay? And again, we went right through here, and we're checking everything out. Then there's cavity setup. Use vertical cavity dividers for best overall operating results. Now, again, that's really more for pro-level machines. Again, we're dealing with civilian-based machines. You really don't got to get that technical. The big thing here is that we make sure that the cable chain is properly set so that we allow all of our cables up to their minimum bend radius. Now, that's another term used where many guys don't even know what the hell I'm talking about. Every cable in production, regardless of what it's used for, what genre, has a minimum bend radius. Smaller cables in diameter have a larger minimum bend radius. Larger cables in diameter have a smaller cable minimum bend radius, or excuse me, a larger minimum cable bend radius. And that's due to the fact that naturally its diameter is larger. In order to achieve the longest possible operating results in conditions where minimum high and by are not possible, it's recommended to use cavity dividers. Follow these procedures. Keep unlike components apart. Keep unlike cable or hose jacket materials apart. When cable or hose diameters are less than 60% of the selected or available intercavity total height, individual flat cables must be kept separated in private compartments. This will prevent cables or hoses from tangling and damaging. Aid in maintaining the best left-to-right symmetrical weight distribution and balance of the carrier cavity contents. Ensure maximum cavity fill should be less than or equal to 60% of cavity area. If in accordance with the previously mentioned recommendation, it is found that cavity dividers are required, as mentioned before, the sum of the dividers should be added to the total sum. From this, the new chain width can be determined. If this new width is wider than allowed, stacking certain cables or hoses is possible during horizontal shelving. It is at this stage that the suppliers usually ask end users to contact them for expert advice, but we don't buy enough from them, so the chance of them helping us is slim. So again, basically what he's saying is you can naturally elevate your stacking. If you're stacking cables, a lot of guys do that. What they forget is when they stack, if it's not done properly, that's why they're asking the manufacturers, or he's recommending to ask the manufacturers for recommended advice, because they're experts in their field. They manufacture the units, and of course they want to make sure that you're not going to have premature cable failure. Okay? If dividers are going to be used, important to decide how are they placed. Most suppliers default to placing dividers every second link, maximum separation distance of ½ meter. The rule of thumb is the more cables there are, the more dividers should be placed. Okay, once again, that's more advanced, but if we're dealing with a lot of cables, and I don't know who I'm talking to out there, I know there's a lot of guys dealing with pro-level machines, think about what you just read there. It's very interesting. Here we start talking about bending radius, and this is going to come in as we go all the way through this, because like I said, this is a different video, and I really hope everybody watches it to the end. When selecting a cable chain, always choose a chain that has a minimum bend radius that is equal to or larger than the largest cable minimum continuous bending radius. So if your largest cable is 15 mil, the minimum bending radius should be 15 millimeter or bigger. The larger the bend, the longer the cable will last. Let's read that again. The larger the bend, the longer the cables will last. And that's common sense, guys. There's less stress. Less stress on a cable. So much less stress that I'll say this, and we can all basically agree on one thing. We've seen some cables fit in cable chains and CNC that really don't make a hell of a lot of sense. We've seen everything from wood routers being used with actual cables that are not designed for CNC use, but they never have problems. They never have problems. Wonder why that is. Well, we know that they're really not designed for this application, but they're softer cables. Yes, that's true. But typically what it is the chains are so small, and they're usually running one or two thin cables inside there. There's plenty of room. So therefore, there's no real push and pull really going on with friction really driving on that cable. Will it last as long as if it was in general use when you typically use a wood router from Home Depot or Lowe's? We don't know that. There's no way we've done a time study, and if there has been a time study, God bless them, but I don't know that information. I'm just stating what I know to be fact. Many of you know to be fact, because if we do a Google search, we can find at least, I would say, 400 to 500 routers out there. Hell, if you just do a search on YouTube, we can find numerous amounts of routers out there using wood routers inside cable chains as far as routing their cables, and never have a problem. So it's interesting to really factor in bending radius, which none of those are ever discussed on those cables, but they, of course, regardless of how flexible they are, they still have a maximum or a minimum bend radius, and it's very, very seldom discussed. Selecting suitable cables. This is interesting. This is a part that I really couldn't wait to discuss. There are many different types of cables on the market today. All of the varieties, only a few types are designed and constructed to be used in cable chains, of which there is only one type or two construction methods. The second method is very expensive, so really there's only one type of cable we can use. I have not included cables for fixed installation. These obviously don't work for very long. Also, please don't use flexible cables designed for home use, like extension cables. These jackets are not designed for the abrasive environment of a chain. Now, that's interesting that he said this, because some of this I agree and some of this I disagree. And I disagree like many of you do, because we realize that cables over time are all going to degrade. They are consumable items. In any capacity for whatever item we're working with, a cable in engineering is considered to be a consumable. It will eventually fail in one capacity or another. Either it's overflexed, either the terminals aren't holding up, something may give. But in a robotics use, it happens at usually a more accelerated pattern because we're dealing with motion. Now, that being said, when we look at this and we see this, and he's saying, you know, don't use things like home extension cables and whatnot, yet if we go on YouTube, we see it being done all the time. But how many videos are done where a guy says, hey, you know what? My cable chain caused the failure of my cable. I've never seen a video on that, have you? We know it happens. I'm sure it does, but no one ever says that. It's interesting. It really is. But when we think in terms of what cables can be used inside of a cable chain, what exactly is a cable chain? Well, we know it's a bunch of links, and it basically forms a pattern like this, and we'll cover it as we go down. But basically what we got here is types of cable stress. We have continuous flex. You can see here they actually used a cable restraint right here, and they're just showing you that it goes back and forth. Then we have torsional flex, where it would actually be rotating. That you'd see more on a multi-axis robot. You can see right here, consistent twisting. Bending flex. In such case, the cable is flexing back and forth off a stationary point, once again, depending upon what we're talking about. He gives you the definitions. Very, very interesting stuff. In such cases, the cable is rolling back and forth in linear motion, resulting in the cable and the conductors within to flex in an equivalent way. This is typically the case for all cables that are approved for use within carrier cable systems. Where required, bend radii are typically 10 times the cable outer diameter or less. So, again, we're talking about bend radius. They're saying 10 times the cable outer diameter or less. Typically, I go with an 8 time on my cable for minimum bend radius. But again, that's the max. When I say the max, that's like you running 3.5 amps on a motor. It's not typically seen if it's the peak rating of the motor. 2.7 amps will be your RMS, which is more worldly in terms of actual real-world use. But these are still good numbers to play with. Okay, and they're still very, very viable for applicational use. And this will all come up later on, so I hope everybody's paying attention, because, again, you guys are going to use this information. It's so interesting to see how many systems I've seen not cover, excuse me, not covered this information in detail. I've really, like I said, it's very unique. You can see here understanding cabling techniques. Unilayer bunch. In such cables, conductors, copper groups, or bunches of wire strands of any number are twisted together with the same lay direction. You can see there, and we've seen that before. That's typically what you'll see in conductors, where they're actually usually inside the conductors. You'll see that where they're grouped. This is concentric, centrohelical, and you can see concentric unilay, depending upon what we're looking at. Now, again, this is dealing with more industrial standards. We're not dealing with that. We typically deal with the straight-up cables, or as far as conductors. And now we're coming here to the chain setup, and this is where things get interesting. All too often, those more commonly selected or used industrial cables are not designed for constant flexing or bending operation as seen in cable carrier systems. They will quickly corkscrew. And let's see here. I guess that's, yeah, he just cut that word off. Especially when running within a tight cable carrier bend radius. Now this is interesting, because this part of the sentence right here speaks a lot. They will quickly corkscrew, especially when running within a tight cable carrier bend radius. So the question is, would they corkscrew if they weren't in a tight cable carrier bend radius? I can tell you from personal experience that is typically not the case. In real-world use, corkscrewing will happen, but it only happens when the cable is confined and it's not allowed to properly move freely within the cable chain, providing the cable chain is an adequate size. Now, this is something you guys can test yourself. I'm going to do a film, or a short little excerpt, I should say, on a cable chain with my spindle cable, and I will show you that inside the cable chain. Okay guys, I've got a sample piece of cable chain right here. This is very similar to what many of you are using. You can order this off Amazon, you can order them overseas, whatever you choose, they virtually all do the same thing. Of course, this chain is what's more commonly used. Again, the video was discussing chains with separators. This one does not have separators, but you can see the amount of vertical clearance we have and horizontal clearance. Here's my 16-4 double shielded spindle cable. If you've never ordered from me before, of course, the cable gets rolled up like this and is shipped to you. Once you receive it, the main thing you should be doing if you're going to insert the actual cable into the chain, you're going to naturally terminate the cable first on both ends. In this instance, we didn't do that. From the cable being actually wound up, you'd want to unroll the cable. I'm not going to unroll all of it, but I'll unroll most of it. Just do it in a second. A lot of guys skip this step, and what they'll do is they just insert it right into the cable chain. What you want to do is lay the actual cable out so that there's the least amount of stress on it. You can see we got some glue here on the cable because it was actually taped. But you want to lay it out straight with your terminals so that there's, once again, it's as straight as it can be with the least amount of stress. Once you've done that, you have two options. The first option is to disassemble the actual links in the chain and actually insert the cables into it. If you do that, keep in mind, you got a lot of work ahead of you, okay? A lot of guys are not going to do that. Most guys, what they're going to do is take the chain and just generally insert the cable into the chain. They do that with all of their cables. If they do that with all their cables and you have any pinching going on, you may not see it. So again, up to the end user on how they actually assemble their cable chain. My recommendation is if you're going to do it that way where you're going to insert the cables in because you don't want to disassemble the chain, insert your cable, and you want to do it in a manner that's going to go through the whole chain. And now it comes out the other end. And of course, we want to make sure, this is just an example, but we want to make sure you have enough excess cable on whatever you're actually hooking up, whether it be for motor cables, whether it be for spindle cable, whatever it is, that it's going to come out and it's going to appropriately fit the chain. Now, of course, this chain has nothing in there. It just has the one cable. But you can see how the chain wraps right around. I mean, this is not rocket science. You can definitely see here the fit. The big thing I've seen done, and many of you have seen done, I'm just going to straighten this out a second, is the fact that guys will typically order the shortest cable they can order, and then when they're actually moving on their x-axis, they bend the cable over, and what they forget is when the y-axis comes up, it's going to end up pinching all the way over here and come either pinched here or pinched on the other side, depending upon how much pressure is put on the cable, because they're not leaving enough slack in the cable purchase that they make. Okay, so once again, we're dealing either with friction on these chains being overloaded with too many cables in them and not having the proper clearance like discussed in the video overview discussing how to select a cable chain, or they're cutting their corners in the sense of the cable length, which I've seen done time and time again. As we go on, you'll find the shorter the cable you use, no different than in the video as covered, usually the shorter the lifespan of the cable. Can any vendor dictate lifespan on their cables? Absolutely not. There's no way we can do that because there's no way we can dictate, what are you doing with your cable chain. If you take and properly assemble the cable chain with the cable in it, everything is set, you're going to find the sweet spot. What I mean by the sweet spot, you can see how the chain actually wraps around. There's no stress here on this cable at all. It can move, everything is set. As soon as you put stress on any cable, I don't care if it's this cable, I don't care if it's, once again, one of the German high flex cables, you will find over time
you're going to have a failure. It can either break the seam, it could break the PVC. There's a lot of different variables. Now I have a smaller piece of my cable right here, and you want to see, this would be about your maximum bend radius. Would I recommend anybody be at this bend radius? Absolutely not. You always want to leave a wider gap. What I like to do is let the cable relax. If you let the cable relax in the chain, you can see it finds its own arc. And it finds its own arc because that's where gravity's pulling it. And again, the actual cable's on the bottom, everything is set. Depending upon how long your axis is on your Y, that's how you're going to dictate your motion, and that should also be how you dictate the length of cable. I've told many guys that want to measure for the proper length cable, take a string, run it through your cable chain, and it'll simulate a cable. Now, is it going to simulate the way the cable moves? No, it's not. It will give you a general length. In order to increase in order to take an accurate length, I recommend increasing it by at least 20%. And that gives you a buffer, because once you run this cable through the chain, you're going to lose actual length in your actual cable. So the thing is very simple. Once the cable is actually set in the chain, and you figure out how much cable you actually need, you can see you can bend this virtually anywhere you want. You're certainly not going to put stress on when you're right here. This is nothing. It's when we come over here and we get tight, that's when most guys have stress. They come back over here, and if they're too close, they're going to do this. They pinch the cable, and that's what fails. When guys complain about seam breaks or any type of issues with electronic cables, if you're just crimping them, and again, this is a double shielded cable, if you keep crimping it, you have to remember you're dealing with 2 levels of shielding, okay? You have to use common sense. This is industrial cable. It is designed for CNC use. It is, of course, PVC, like virtually all spindle cables, unless you're buying, once again, those ultra high flex cables, which technically are only required in certain machines. You don't need to use that all the way across. It's typically up to the end user. But I can tell you right now, when you set the machine up properly, you leave the proper length, you're going to get one hell of a system. This will never cause problems, and you can see, once again, she'll travel. If this is plugged into your spindle right here, as she travels on the X and comes back, you've got plenty of room. You're not going to have, you can see how the arc in the chain, or arc in the actual cable is. Everything here is perfect. Everything. So again, keep that in mind. Use this as a general overview. Again, if you're putting in multiple cables, you should not have friction in terms of when you go to handle this chain with your cables loaded. It should move extremely free. If it's binding or doing anything when you're moving it by hand, it's sure in hell going to do that when you hook it up to the machine. But I find guys usually skip that step. They say, oh, I'm just going to load the cable chain and go with it. We see it all the time. Don't do that. Don't be in a rush. Take your time. Go over it with the detail it needs, and I promise you, you're going to have a buttery smooth system. The cables will last longer, and you guys will save a lot of money in the long run.
And it's interesting how cables behave, because a lot of guys don't realize that even if the cable's in the chain by itself, the cable or the chain, as it moves fore and aft, as it would moving on the x-axis fore and aft, actually moves slightly outside the actual chain. So where the cable exits the chain, you will see that the cable is it's constantly in movement. It's very minimal if the appropriate size cable is used, but it is still present. Now, when I said minimal, if the appropriate size cable is used, highlight that term, because again, minimal is only based on the appropriate size cable being used. If you use a smaller cable, all of those forces are amplified. Okay, you can see here, he says wrong cable's bend radius is larger than the carrier's, forcing the cable to push against outer radius of the cavity of the carrier cavity. So basically what they're saying is, if there's pressure coming over here, figure this outside tube, if there's pressure of your cable coming over here and pushing on the cable chain, we don't want that. We want the chain to be actually laying the cable in where it's just around and it's fine. Now, again, when we talk about that, let's talk in terms of logistics. In order to have stress on a cable pressing against the chain, it would have to virtually be jam-packed in here. Most cables from gravity would just sit and flop over. Now, they're certainly not going to hug the top up here like he's showing. It would hug right here like you see here. more or less as it comes around. Now, again, it would be on the bottom. Where you see it come here, it would actually come in and lay down. That's essentially the ideal solution. And again, it says right, cable's bend radius is less than or equal to the carriers, allowing the cable to lay comfortably in the carrier cavity. And why do we want that? We want no stress. Stress we have to eliminate. And why do we say that? I don't care what the cable is made out of, and we'll cover that. Whatever it's made out of, whatever material, all of these high-dollar German cables, I've seen everything on the market. Some of them are beautiful, don't get me wrong, but I'll tell you what, if you can use a DeWalt router's power cable inside a cable chain, regardless of it being best practice or not, we've seen it done consistently, and no failures being noted anywhere, or at least not documented on YouTube, I've never seen one, then you already know it can be done, and it's all based on friction. Friction is your biggest enemy. Anybody will tell you that. In anything with motion, friction is going to degrade parts the fastest. Okay? As we come through here, let's see, and then we've ended at this sentence. Also, many standard industrial cables a bend radius larger than most machinery applications allow, and as a result, force these cables at a tighter than recommended radius. This will undoubtedly substantially reduce cable life. A cable specifically designed for continually flexing tight bending radii must be selected. Now again, define tight. I don't know what that term means. In CNC use, we have different spindle cables, we have different motor cables, we have different PVCs, we have TPE, TPMs. You have all types of material used for cables, and the bottom line is this. Whatever material is used for the cable, if you mitigate the amount of friction from that cable and you mitigate and pay close attention to exceeding minimum bend radius, that cable will typically work fine. Now, does that mean it's the best cable for that application? No, it does not. No, it does not. Do not take what I'm saying lightly, because I have guys that'll go off the deep end with that. What I'm saying is we have to be realistic. Cables are designed for flexing. If you stay within their actual limits, you will be fine. Many cables are made with different substrates. It says here, as we come over here, you can see it says some commonly used cables also use a cotton tape between the inner conductors and the outer due to the constant bending. When operating within a cable carrier system, this cotton tape will bunch up underneath the jacket and crimp the conductors, causing premature cable failure. Well, again, if you're using a cotton tape, I don't know, I've never seen a cable use a cotton tape, but personally, again, in Europe, they may have that. Bottom line is anything binding conductors is going to lead to any possibility of problems. Cables with a built-in twist will develop a corkscrew effect more easily. Additionally, the inherent further amplified by the constant flexing relative movement of the cable operating a cable until the cable conductors break. It makes total sense. I've heard a lot of guys talking about using spiraled actual conductors, and that's a no-no. Whether it be in motor cables, whatever else, your best bet in most applications, unless they are using the proper flex outer exterior, you would find that you're golden in terms of flexing when we're dealing with amplified use with multiple cables, especially with cable chains. When we're dealing with motor cables and we're dealing with multiple axes, of course, you can have 3, 4, sometimes 5 cables going in the chain. That's where everything becomes more and more amplified. So paying attention to that really pays off. But bottom line is any type of tape or binding, if there's any type of binding on anything, you're going to have a smaller level of actual bend radius. Or actually, I'm wrong. Your bend radius will actually be higher. It will have to, minimum bend radius will have to be higher to compensate for the actual cable being wrapped up in whatever capacity is. Now, this is always prominent in shielded and double shielded cables. Now, I know guys will say, well, there's all this new cable out from Germany, or this cable, you know, this is the ultra flex version. And it's like, okay, but guess what? It still has a minimum bend radius. So regardless of what cable you're using, the bottom line is if you're not using the proper cable, in terms of, when I say proper cable, in terms of how to use it for that application, you're still going to get the same effect. You still will cause premature failure. It's inevitable. The best choice for a cable, and this is really interesting, this is probably the best paragraph. The best choice for a cable to be used in a cable carrier should be PVC, PUR, TPE, TPM jacketed. Cable jackets made of rubber and neoprene are generally not recommended. The latter two materials too sticky, do not allow the cables to move easily relative to one another, and cable carriers will also contribute to aforementioned cable knotting. Again, cable knotting typically only happens when, once again, we have that binding effect, where there's pressure and the cable can't move freely and it keeps bundling, and then it just collapses upon itself because the motors basically compress the cable. And that's how it happens. It actually locks the cable in, and if the cable is locked in long enough, whether it be from friction because the cable chain is overloaded or the cable is pressing against the outer wall here, you will get that binding and it will cause that corkscrew effect. So it's very interesting to pay attention to this. When installing cables or hoses into the carrier system, they should be laid into the carrier without twist and in accordance to the guidelines in the image. Cables or hoses should not be simply pulled off the reel. Instead, they should be properly uncoiled from the reel, also shown in the image. And that's interesting because a lot of guys think you just install the cable and you're good. No cable I've ever seen just lays flat. And when I say lays flat, your conductors are always going to be manipulated to attach on one end or the other. You should lay the cable out completely, let it relax, figure out where you're moving everything so you can remove as much stress as possible. This is just, see, to me, I'm sorry, I feel that's logic in my eyes, but I know that a lot of guys don't think like that. They think, I want to get my system running as fast as possible because, you know, that's who I am. And then what they'll do is just throw it through the cable chain and wonder why, you know, they have problems. So think about these details. Think in terms of money, and you're all of a sudden going to see the capacity at which you'll sit, and usually you'll sit and snap your fingers and say, man, I forgot about it. I didn't even think of that. That's something I didn't think of. And that's why I like these kind of videos, because it really makes you think, you know, did I do that? Could I do this better? Because I'm telling you right now, if you implement what's going on here, you're definitely going to save yourself some money with premature cable failure. After the carrier system is properly installed onto the machinery, and likewise the cables and or hoses installed within the carrier system, the entire system should be initially run off at slow speed to ensure that everything runs freely and smoothly within the carrier cables and or make sure no hoses are binding. This is imperative, guys. You're running your simulator, you're double checking, does everything feel good? You should be able to watch your cables move, everything move in motion, no weird noises, no weird binding. If you hear tackiness like rubber sticking, you know you have problems. It sounds ridiculous that I have to mention this, but again, I feel that details are everything. And again, that's what I feel I try to separate myself from, is that we look at every detail. The more we can isolate the details, the more this robot will produce and perform what you expect. And I can't explain that any better than that. Check that all cables and hoses are not installed too tight, stretched between carrier bars, or too loose, hanging in the carrier bars. Again, most of you are not using those. Inside the carrier system when clamping them into place. Optimally, aim for the neutral axis, center line of the link of the carrier system is shown below. Any adjustments to the carrier position or alignment, as well as cable and or hose position length, should be done at this time. And I tell you guys, do that very carefully. A lot of guys just pull stuff. You know, they're not thinking, oh, I'm just going to pull the cable. You know, I'm going to move it to the left. I'm going to move it to the right. And all of a sudden, they have all kinds of problems because they're overloading that cable. And again, friction comes in the key. You might be pulling 3 cables through the actual cable chain. You're not taking into account that there's friction, and you're not just moving 1 cable then. Typically, you're moving all 3 or however many quantity is in there. So think about that. Once the entire system is double-checked, everything should be firmly tightened down. Important, each cable is required to be individually strapped down and not bunched together and then tied down. Now, we know in our cable chains that's not usually possible. You could do that if that's something you wanted to do. I would not recommend it in most of them because they do not have the cable separators as disclosed above, so you'd be actually putting more stress on. Once again, we're using this as general knowledge. Most of this information is extremely well done. Some of it is only pertaining to more, like I said, more of a professional grade system, so keep that in mind. Only after this installation and double check procedure is completed should the track be powered up to full speed and duty cycle. And I recommend doing that over time, guys. I don't recommend, if you're just setting your system up, get everything squared away. Make sure your coolant's on. Make sure your motor cables look good. Everything is good. There's no weird noises. And when I say weird noises, this is so interesting because I have guys that'll say, well, oh man, the axis sounds so great, everything sounds great. And then when they'll send me a demo video, like watch me run this, this project, and then I hear like a stickiness in the background, or you hear an odd noise that you just can't put your place on, and usually it's because it's a rush. It's a rush to get, like I said, the machine done, or on the other side, it's that financial click again, where it's like, hey, I cut a corner here just to get the job done. I use a cable that's 2 feet shorter than I really need to get the job done. That's not what you guys want to do. It really isn't. You want to take your time, do it right. It's always a good idea to recheck the chain after a few hours at full speed in case of any cables have slipped or stretched while running at full speed. Now, guys, I'm going to tell you right now, I did a video on features in Mach 3 you may or may not know you have, and it actually discusses how to check the maintenance hours on your system. Now, everybody should be doing that. That's something everybody should be doing. Full-scale operations do it, and you should be implementing what full scale does. I don't care if you run your machine only on the weekend. That's imperative for you to go through and say, well, I've got 3 hours, 4 hours solid on the machine. I'm going to just check everything, make sure everything's good. You want to save money? You follow PMs, preventative maintenance, and you will save money. It works for full scale. It's going to work for you as well. There's no excuse for that. You own your robot. You are in charge of everything. If I'm a pilot and I go to fly a plane and I don't check my checklist and I crash the plane, who's responsible? Okay, bottom line is, even if the hardware failed and it's on my checklist, I'm still responsible. So remember that. Own your robot. Own it. And I say that with a lot of passion because I get guys, as we go through this, they're not owning their robot. This is an amazing image right here, actually group of images. Failure types. Catastrophic cable failure, extreme cable movement within the carrier system, possible causes, incorrect cable for application, missing cable strain relief, insufficient cable or cavity partitioning. Here's what they mean by the knotting effect. This is what you get until it finally breaks through. If it breaks through the PVC casing and you are using shielded cables, guys, you could potentially have a dead short on your hands and a cable fire and a meltdown. So very, very dangerous, very dangerous. Not typically seen, thank God, in our smaller systems, but definitely seen in larger systems. Carrier system failure, obstruction within operating envelope and tearing into the carrier system, possible cause, misaligned carrier system, incorrect installation, inadequate inspections, application modifications after initial carrier system installation, carrier design incorrect for application, limited carrier envelope space. So again, we're not usually seeing stuff like this. You can see this outside or definitely in an external environment. This is the biggest failure amongst most of our CNCs. You're seeing it right here. Cable and carrier system failure, trying to fit 8 gallons into a 5-gallon pail. And that is no BS. That is exactly what we see there. That I see all the time. Many of you see that all the time. And this looks like, oh, he's trying to be neat. This isn't neat at all. This is a cluster screw right here because we've got, I don't even know how many cables. You've got 3 on the bottom. He's got God knows what on the top. Then you got zip ties everywhere. People forget zip ties put stress on cables all over the place. Again, classic overfilling of cavity space, carrier design incorrect for application, limited carrier envelope space, yet additional cables. And then it says hoses added anyway, after the fact. Overloaded carrier system, no cable hose strain release. This is horrible. This will destroy your cables very quickly. If we have penetration, once again, with double shielded cables or shielded cables in general, of a conductor penetrating the casing it's housed in, and it penetrates into a shield that's grounded, you will have a dead short. And you can rest assured, once again, we're in tune for a cable meltdown. Okay? Very serious. You want to print something, print this, put this on your machine, and make sure your cable chain does not follow this example. This is disgusting. And I hate to say it, this is what we typically see. This is what I typically see, and many of you see online. This is what you see. Maybe not to this extent, but you see these chains overloaded, and they're just stuffed packed full like sausage, and then they wonder why, oh, they're putting the water hoses in there, I'm putting this in there, I'm putting that in there, because they do not have the competence to look at this and say, you know what, this is what I need to do. So I hope they find this video. I want you guys to learn this stuff. We have to be careful with our systems. Once again, own your robot. You own it. Don't expect anybody, whether it be a vendor or anybody else, to be responsible when your incompetence is leading to stuff like this, because over time you may be okay. Big question here, we see these cables coming out. God only knows what each one of these costs. We don't know the length or anything. If one of these failed due to this use, it certainly isn't anyone's fault but the end user. You're not going to call the cable company and be like, oh yeah, your cable failed. And you're not going to, most of them never disclose this. They'll say, oh, the cable failed. You don't see pictures like this. As a vendor, I can tell you I don't get pictures like this. Do I know what happens? Of course. I think we all know what happens. Look at YouTube. You'll find out how many times it happens. So once again, this section is simply added to help you identify if your chains are set up correctly or to help save future mistakes. Cables that have failed due to incorrect installation typically show the following symptoms. Corkscrewing where cables twist in themselves, knotting of conductors underneath the cable jacket. Cables twist around one another within a cable carrier system. Cables are sticking out between the cable carrier crossbars. In your case, most of you won't be dealing with that and getting caught in the bend radius. Cables entangled with other cables and crossbars, tearing them apart. Loss of conductivity through simple breaking of cable conductors. You will see this. You will see this in most of our cable chains. Common cause of cable failure when operating in a cable chain. Cables used are not designed for use in continuous flexing operation. I have to say this, and I'm just telling you in real world use, this is typically not the problem. What I mean to say, and I've just proven it, many of you have seen it online, we've seen it everywhere, and I'll say it again, you can get away with using a lot of different cables if they're not under a lot of different stress. Movement is possible. Long as movement is possible and there's less friction, is it best practice? Absolutely not. Am I saying to do that? Absolutely not. But by the same token, let's be real. Continuous flexing is a term that's used in the industry. However, in CNC, virtually every cable is continuously flexing to a degree. The question is that cable put in a confined space with limited movement to expand and contract based on movement of the robot? That is what leads to failure. That is truly what leads to failure, because it's either going to bunch up corkscrew like they're talking about, screw up your leads, or it's going to pull continuously. And over time, the motor strength will destroy that cable. You can rest assured of it. Cables are packed too tight inside the carrier cavities. We see that. I would say these right here, or this one right here, let's see, and this one right here, these three. One, loss of conductivity through simple breaking of cable conductors. Cables used, not designed for use in continuous flexing operation. That, I would say, is, it's there. Cables are packed too tight inside the carrier cavities. What I really feel is that. This, I would say, actually, it's the two. Loss of conductivity due to the simple breaking of cable conductors, and cables are packed too tight inside the carrier cavities. Those are probably the two biggest culprits. Friction and just overstacking everything. The actual operating bend radius of the application is smaller than the minimum bend radius recommended by the cable manufacturer. This as well. This is something that has occurred. If I get questioned, or I should say if I don't get questioned on what's the minimum bend radius I can apply to any cable I purchase from you, I already know that this person's not looking at details. They think they're buying a cable that they would use to run, their TV, and they have no idea what they're really working with. These cables are not designed for general use. You're buying an industrial cable. That means, once again, you're responsible when you buy that industrial cable. I do not know what you don't know, or any vendor know what you don't know. If you don't ask, we assume you know. If you ask, you're supposed to get the knowledge that you're paying for. But if you don't accept that in terms of making us know, there's no way we know. So guys, pay attention to this. The actual operating bend radius of the application is smaller than the minimum bend radius recommended by the cable manufacturer. If you don't know the minimum bend radius, you can easily destroy your cable inadvertently just by guys saying, oh, I just put it in a cable chain. I just put it in a cable chain. I don't know what happened. I have no clue what happened. The cable chain I installed it in, and the spindle died. Okay, he's thankful to be alive. He should be, because he's lucky the cable didn't melt down. He didn't actually penetrate the actual PVC casing in most cases, or whatever, whether it's a super flex cable, because again, guys never claim they fail, but I can tell you right now, they all fail. They all fail. Once again, if they're installed incorrectly and used incorrectly. Cable carrier design is not cable friendly or optimal for the types being used. Minimum bend radius for the cable is larger than the chain's bending radius. That makes sense as well. Different types of jackets, cables, and media hoses mixed in the same compartment. That's an interesting one because it kind of confines with what we were saying earlier, being overstuffed. I get a lot of guys that want to do all their water hoses, everything in it. You know what? If you can keep them out, keep them out. Why not keep them separate? Here's a thought. Let's think logically. What happens if that water hose breaks? It's going all over your cables. If it breaks externally, at least you have hope to get it and service it quick. If it breaks inside the chain, you're SOL. You have to figure out, I got to tear the chain apart. Meanwhile, everything is drenched. And I've seen it happen. And I can't tell you how many guys do it. I don't recommend it unless you absolutely have to, or if you're using a wide enough cable chain. But I'll tell you what, you would need one hell of a cable chain to do that, and they're not cheap. Many of you know that. Again, a lot of guys think they're making their system neater in some capacity, when really it's just a lack of competence, once again, of understanding what they're working with and what they're waiting to happen, because over time, remember, most of us use vinyl tubing, which is normal. That's normal in the industry for what application we're using with water-cooled spindles. Over time, it will erode, and if it erodes the wall and you get a leak, you're climbing in there to mess with that cable chain. You got to disassemble everything. It's a headache. It's a complete headache, and you really don't want to have that happen. Let's see, different types of cable jackets, different type jacket, cable, media hoses, mixing compartment, varying cable sizes in the same compartment, makes sense. Again, try to keep them spaced out like we saw in the earlier description. Some compartments are full while neighboring compartments are empty, and that happens a lot too. That's where you'll see, I mean, it doesn't happen that much. It's kind of like where the chain is unbalanced. You'll have weight on one side, not weight on the other. A lot of times guys don't even think of that. Once again, it's in the chain, it's good. That's their mentality. It does not work that way. Build it in symmetry. Build it in symmetry without friction, you're golden. Strain relief, sometimes incorrect, missing once in the field. Strain relief, again, in our chains, really not too common. You can implement it, but proceed with caution with that. Bending radius of chain is too small for cable. I have seen that. A lot of times that occurs with chassis that are really small. And like what you'll typically see is the base chassis models, the ones that are on the ground. And those are the ones that usually you see that on, where basically it's like two Y-axis with the X, and it's coming across with the gantry, and it's mounted just to a table. I'm trying to think of them. There's so many of them. Shapioco is one of them, I know that, and there's a couple others that are like that. But those are notorious because the chain is usually too small. It makes a very, very, very tight arc, and what the end user does is he'll use that chain mounted on the chassis, keep the arc as tight as possible, and then it can usually cause all kinds of problems, especially when the cable chain is overfilled. Because when it's overfilled, you have that tight arc. Not only is it putting the minimum bend radius strain on the cable, making it ricochet off the interior wall of the cable chain, but you also have added friction then of all the other internal tubes and everything else going through there, and guess what? You're SOL. You will find that your cables will fail very, very prematurely. Movable dividers are causing cables to shift in unfavorable positions, in many cases causing damage. If you plan on designing a chain in the near future or want to improve your current design, I hope you find these tips useful. He tells you what brands he uses. Once again, great article. I tell you guys all, check it out. I hope you're watching this at least to this part, because there's a lot to learn here and it's really good information. Now, let's go into practical use. And I'm going to go into practical use in an instance that happened to me about a week ago.